Hello and good day to you. So today I'm just showing off some more work I've done on my decision tree. I've got it running here. It's trying to categorize voices into male and female using a bunch of data from their mean frequency, which, as always, you can find on Kaggle and the voice gender recognition by speech analysis data download. What it does is tries and finds split points within the numbers. So rather than just using entropy to figure out based on labels, I've significantly updated my program. It now scans through numbers based on a gradient that you give it as a hyperparameter, which is basically how many times it's going to check an individual variable and slice it up to, C. So you can sort of, you could set it to run 100,000 times on each variable if you wanted, which I'm only doing, I think, 10,000 iterations between each variable, and you can see it takes a little while. I've got it running for ages. I've got it doing 45 different decision trees in a massive random forest, just for the reason of stress testing it and seeing how good the end result is. I haven't actually ran it to the end. I found it's really good at categorizing female voices and finding lots of rules that, explain why a voice is female. Not so good on the male, though it does find, as you see, rules here and there. It's just that there's a really big split point that it finds really early on. 189, 77, 189, 77 for female voices, which it just goes, that's a female voice. Go figure. I've had to do a lot of work on the actual algorithm, simple things of, because it's all functionalized and in the class, I've just added and changed on a function to control creating the different trees, and a couple of different methods of ways it could create trees that you could hand it as a hyperparameter. I had to upgrade, I didn't even have to touch entropy. I had to upgrade how it did the filtering, so that it would do numbers, because previously it was treating everything as a string. Now it identifies numbers and works out a scan range, and basically gets a hyperparametrical gradient which tells it how many times to test any given number between its max and minimum. And so basically creates slices between the max and minimum of numbers it's going to test, and sees if there's any improvement of the entropy, any lowering of the entropy for a given test that it's doing. And if you remember the last video I did on decision trees, what we're looking for is the lower the entropy is, the more pure the resulting node is, and hopefully we then get to what this is doing, which is finding lots of leaves, where the leaves give an explanation of what gender or what the answer to the question is. So why would we do it as a random forest? Why would we do lots of decision trees rather than one decision tree? So let's look at that. I did my nice painting skills, and you can imagine that this is happening for every single variable within this data. So every single number, there is female, that's still on the wiggly line, straight line, female, male. Now there's probably a nice easy split point there, as you can see, and you get a large number of females voices in one go. And as I said, this finds that sort of thing quite easy, and goes, oh, mean frequency, if it's really low, woman, and finds a nice split point. The problem is, if you don't code it properly, what it can end up doing is going, well, I find a nice number over here, and I find a nice number over here, but that's only categorizing one person. But it's because when I first wrote my decision tree, it was designed to when it just find the least entropy. Well, you can't do that when you're doing a decision tree with numbers, and maybe there's probably a better solution than using entropy for a number-based decision tree. I'm still learning my machine learning and still getting better at it, so forgive me where I get it wrong. But I therefore had to sort of work out a way to get it to not only keep on scanning and find places where it maximised the cut within the data. That did create a unfortunate side effect that it meant that it had to run for quite a while to find these sort of right parameters to find where each split should be. But it now does that, and hopefully when it's run this course I can get a bunch of data that sort of manages to say that this is a good categorizer for male and female voices. The data set on Kaggle says that a random forest gets around 96-98% accuracy. I mean, this has been a nice teaching lesson for me. I did a few whoopsies with it. One point got frustrated with it and started thinking, well, I'll just buy a beer and I'll just sit down and look at this and get it sorted. And during looking and getting it sorted with a beer, I probably put in more bugs. But I've also been interested how many times I've changed this particular bit about the numbers. At first it was going to find a point where entropy is 0 and then scan through the rest of the possible values and maximize t being the number of pure values at the node. But I soon realized that meant that sometimes it would find this and just find where it categorized just one man. So now it every single time it runs, it scans through all possible split points, finds the one which is not only a clean split point but maximizes the return value on that split. So you get your biggest splits first in the data. I'm kind of proud of it. It's been hard figuring out. It's nice little learning lesson of keeping everything functionalized, keeping everything nicely object orientated. It's a nice lesson in thinking about statistics, because this didn't occur to me first time round. First time round I just thought, well, it will brute force it and it will find a nice split point and that'll be fine. Actually, particularly when you add in these extra complexities, it doesn't necessarily work like that. So that's where I got to. I've got a homemade random forest. Yay! It seems to work. Yay! It's probably going to require me to learn more about these decision trees and how they're formed. And while I'll probably go away from this and do something else for a bit, I can imagine myself coming back to this with different hyperparameters and different ways and methods of doing it, trying to test my learning on this particular data set, because it's quite fun. So if you haven't already tried it, you can get some data from Kaggle for voice gender, maybe look at Python and something like NumPy or the like, and you can hopefully get a decision tree set up. Many thanks, have a good day. Bye.